In this video, we're going to use the fundamental identities to establish trigonometric identities from 6.4. I'm going to be using the whiteboard to present these problems in a way that's more consistent with how they're going to be presented to you on a test. And further on in math, there's some fill in the blank type stuff that's going on in my labs, but I just want to present these problems to you. Our first one is based off of 6.4.21, and it is secant theta times sine theta is equal to tangent theta. We want to establish this identity, so we want to take the side that's more complicated, change it into the side that's less complicated using fundamental identities. We don't want to use what we're trying to prove the identity. So the first thing that I see that I want to do is probably change the secant into a 1 over cosine. And while I'm at it, I'll just throw a denominator of 1 down here under the sign so that I see multiplication of fractions. 1 times sine is sine. Cosine times 1 is cosine. Keep this right-hand side alone. Don't touch it. That's the whole idea of establishing an identity, is you're only touching one side and leaving the other side alone and using steps to prove that you're going to get left-hand side is equal to right-hand side, like so. And our reason that we can do this is a quotient identity. You might want to justify each step here. This is multiplication of fractions. This is a reciprocal identity. And you get the idea. So let's try another example here. So this problem is going to be like 6.4.25. And it's going to ask us to establish the identity that in parentheses tangent of theta plus cotangent of theta times sine of theta is equal to secant theta. I think you would agree clearly that the right-hand side is more simple than the left-hand side. So let's work on the left-hand side. I only see a single expression over here on the right, so that tells me that I'm probably trying to get a common denominator over here on the left and get rid of this addition here. So let's work on that. That's sine over cosine plus cosine over sine times sine. That needs to be equal to secant. And so far, I've used quotient identities. All right, now I'm going to make a common denominator. And when I do that, that's going to be sine squared theta plus cosine squared theta over sine theta cosine theta times a sine theta needs to be equal to a secant theta. And that's just making a common denominator. Let's just say make LCD and add fractions. All right. Now we're going to have sine squared theta plus cosine squared theta is 1. That's my Pythagorean identity. Sine and sine will cancel, giving me 1 over cosine theta is equal to secant theta. That's just cancellation. And then secant theta is equal to secant theta by a reciprocal identity. Okay. Let's move on to the next problem here. Clear the canvas. We want to establish the identity that cotangent of u minus cosecant of u is equal to a negative sine u over 1 plus cosine u. It's debatable here which side is more complicated than the other. If it were just presented like this to you on the test, it's 6 of one, half a dozen of the other, of which one you want to start with. The instructions in this problem in my labs are going to tell you to start working on the left-hand side. So that's what I'm going to do to kind of help you follow along here. So this problem is like 6.4.39. So let's start working on the left-hand side here. And we get the left-hand side in terms of sine and cosine. It's cosine theta over sine theta minus 1 over sine, and I'm switched to thetas. Be careful, don't switch your variables because that'll get you things wrong in my labs. They gave you u's just to show you that they're allowed to use different variables here. So let's be consistent and stay with u's. Now we have a common denominator, so this is going to be cosine of u minus 1 over sine u. Let's see, these were quotient and reciprocal identities, but let me use that step. Then this is going to be addition of fractions in this step. And we're going to multiply by a unit fraction here. That is going to be a conjugate. So we're going to multiply top and bottom by cosine u plus 1. This is just multiplication by 1. When we do that, cosine times cosine is going to be cosine squared. And then positive cosine and negative cosine make a 0. And then we have negative 1 times positive 1 is negative 1. We'll leave this bottom part factored. Remember, you're always allowed to multiply by 1 and not change the problem. Now we're going to think about if sine squared u plus cosine squared u equals 1, then let's rearrange this to solve for cosine squared minus 1, or you can solve for cosine squared. Let's go ahead and do that. Let's substitute cosine squared u equals 1 minus sine squared u. That's probably a little easier for us here, and we're allowed to take that step, even though that step is not in my labs. So this is our Pythagorean identity here. And then this negative 1 and this positive 1 will zero each other out. I'll be left with a negative sine squared u over sine u times cosine u plus 1. And we'll cancel here. And I'm really done at this point. So that's cancellation is my justification for my last step. I can just rewrite the last step here as negative sine u over cosine u plus 1 equals the same thing, or here, let's do this, plus cosine u equals negative sine u over 1 plus cosine u. And the reason I'm allowed to do that is commutative property of addition. But my labs are going to stop here. They're not going to make you prove that you're allowed to switch a plus b is equal to b plus a. But any step that you take like that, you should be able to justify why you're allowed to take it. Right? Let's move on to the next problem here. Which is 1 plus tangent squared theta over secant theta plus 1. And that's going to be equal to secant theta. I probably would not approach this problem the same way that my labs did, but that's okay. We'll do it their way, and then I'll show you how I would do it and show you that there's more than one way to work this problem. So they tell you to start with the Pythagorean identity that 1 plus tangent squared equals secant squared. And to solve it for tangent squared equals secant squared theta minus 1. So let's make that substitution here. And then we're going to factor. So this is a Pythagorean identity as our justification for what we're about to do here. We're going to factor secant theta plus 1, secant theta minus 1 over secant theta plus 1. Going to cancel. 1 plus secant theta minus 1 by cancellation and further simplifying will be the justification they talk about, because they don't show this further simplifying here, that this is going to be secant theta is equal to secant theta. I'll let you get a good look at that. Again, this was problem based off of 6.4.43. Let me show you what I would do. Now, I'm going to clear this. I'm going to come up here and say that 1 plus tangent squared theta over secant theta plus 1 equals secant theta. And the first thing that I notice is that I only have one term on the right-hand side, which means that I have to get a single fraction over on the left. So I would want to get rid of that addition of 2 terms that's on the left. That would be the first thing my brain would think about. So I would make a common denominator here with this 1. I'm not going to justify each step because they're basically the same things. This is secant theta plus 1 plus tangent squared theta over secant theta plus 1. And right there is my Pythagorean identity. So that's secant theta plus secant squared theta over secant theta plus 1. And I see a greatest common factor of secant theta in the top, 1 plus secant theta plus 1 in the bottom. And those are the same thing. They make a 1, and I'm left with secant theta. Now, that's not how my labs chose to do the problem, but this is why I wanted to show you this on the whiteboard, is to show you that there's more than one way to correctly approach these problems. You're supposed to be creative in how you approach these problems. You're going to think about the problems in a different way than many other students. There's multiple correct approaches to the problem. Just use fundamental identities every step of the way and only touch one side that's complicated and make it turn into the less complicated side using the techniques that they show you in the book. All right, let's move on to the next problem here. And it says 2 secant theta over cosecant theta plus sine theta over cosine theta is equal to 3 tan theta. Again, I only see one term over here on this side, so I'm eventually going to try to make a common denominator. But before I do that, I think that I want to make sines and cosines here. That would be easier for me to see with my identities that I have for tangent. So let's go ahead and make this 2 sine theta over cosine theta. I'll show you what they're going to do. They're actually going to make this secant theta turn into a 1 over cosine theta, and they're going to make this 2 over cosine theta, and they make this cosecant theta change into 1 over sine theta. I think that's a little silly. I would just move them across the fraction bar, but again, I want you to see how my labs is thinking here so you can get all your points. Then we'll go back and we'll talk about how we would do this if we weren't working in my labs and we would just do things in ways that make more sense. So now we want to simplify here, and this is going to be 2 sine theta in the numerator. That it's going to be your box that you're going to fill in. They're going to give you the cosine theta down here, plus the sine theta over the cosine theta here is going to turn into 3 sine. They're not going to have you give any more steps here. And so we're just going to finish this up here, even though they aren't going to justify their answer past this step. 3 sine theta over cosine theta, and sine theta over cosine theta is tangent theta, and that's a quotient identity. Now, as I said, I would just have started off here and written, using my reciprocal identities, I would have taken cosecant across as sine and secant across as cosine, and I would have written this as 2 tan theta plus another tan theta using my quotient identities, and said that that's 3 tan theta. There's nothing better or worse in either of those. So there you go. Are there other correct ways to do that? Yes, absolutely. But that was like 6.4.47. Let's move on to 6.4.57. Similar problem to that. We've got a few more problems here. I know this video is going to be a little bit longer, but that's just how this works when establishing identities here. So cosine theta over 1 minus tan theta minus sine theta over 1 plus cotangent theta. This is minus a -1, excuse me, cotangent theta, like that. is equal to sine theta plus cosine theta. So you see we don't have a single term over there on the right-hand side. We have only sines and cosines on the right-hand side. So they're going to tell us to write everything in terms of sine and cosine here over here on the left. And so we're going to make this cosine over 1 minus sine over cosine. It's not a square. There we go. And then minus sine over -1 plus cosine over sine. And then we're going to multiply here by cosine over cosine. And we're going to get cosine squared over cosine theta minus sine theta. Then we're going to have minus, and we're going to multiply here by sine over sine. That's going to give us minus sine squared theta over, and this is also going to be cosine theta minus sine theta, but they're going to write it as negative sine theta plus cosine theta. I'm just going to write it so it's obvious that it's a common denominator, like that. And then this is going to be sine theta plus cosine theta. Right? Then we're going to have cosine squared theta minus sine squared theta over cosine theta minus sine theta. We're going to factor that numerator, cosine theta minus sine theta times cosine theta plus sine theta over cosine theta minus sine theta. That's going to be equal to sine theta plus cosine theta. And I'll just go ahead and rewrite that as sine theta plus cosine theta is equal to sine theta plus cosine theta. Check. Hopefully you can catch which identities I'm using now. If you have questions, let's go ahead and say these were quotient identities here. Then this was multiplication by 1 on both of those fractions there. Then addition of fractions. And then factoring. Then cancellation. And commutative property of addition. Now let's look at seventh problem for this lesson. Is going to be based off of 6.4.71. And we have tan theta minus sine theta over tan theta sine theta is equal to cosecant theta minus cotangent theta. Again, kind of debatable which one is more complicated because we have a single fraction on the left, but we're going to try and take this left-hand side, which has more things going on with it, and change it into the right-hand side because there's a denominator over here on the left. There's no denominator on the right. So let's split the fractions up here into tan theta over tan theta sine theta minus sine theta over tan theta sine theta. And then we're going to cancel out here and make this 1 over sine theta, and cancel out here and make this 1 over tan theta. And by reciprocal identities, this is cosecant theta minus cotangent theta. I agree that's probably the most efficient way to address that problem. So we'll just leave it as that. Let's take a good look at that before we move on to 6.4.75. Right. 6.4.75, just an example of that one there, which will be our 8th problem for today, is going to be to establish the identity that 1 over 1 minus secant theta plus 1 over 1 plus secant theta is equal to 2 cotangent squared theta. So we are going to make a common denominator here and multiply by 1 plus secant theta over 1 plus, let me just write that in the next step, 1 over 1 minus secant theta times 1 plus secant theta over 1 plus secant theta plus 1 over 1 plus secant theta times 1 minus secant theta over 1 minus secant theta to cotangent squared theta. It's going to give me 1 plus secant theta plus 1 minus secant theta over 1 minus secant theta times 1 plus secant theta. And then we have 1 plus 1 is 2. Secant theta plus a negative secant theta is 0. So multiply these and I get 1 minus secant squared theta. And we're going to use the identity that 1 plus cotangent squared is equal to cosecant squared. So, no, sorry, 1 plus tangent squared is equal to secant squared. Right? Yes. So let's find out what 1 minus secant squared is going to be. That's going to be a negative tangent squared. And missed a minus on this side. Sorry. And negative 2. Right? So we're going to have 2 over 1 minus secant squared is a negative tangent squared theta. So this is the same as negative 2 over tangent squared, which is a negative 2 cotangent squared, which is equal to a -2 cotangent squared. And that's a reciprocal identity that lets us do that. Let's look at our last problem for today for this objective. And this will be based off of 6.4.83. Sine cubed theta minus cosine cubed theta over sine theta minus cosine theta is equal to 1 plus sine theta cosine theta. All right, so this is a fun one to me because you have to remember your difference of cubes. That a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And it's even more fun because there's going to be a Pythagorean identity thrown in there afterwards. But let's go ahead and let's get that first step with the factoring here, that this is going to be sine theta minus cosine theta times sine squared theta plus sine theta cosine theta plus cosine squared theta over sine theta minus cosine theta. And I've got equals my left-hand side here that I can't write out, but just believe me that it's over there. Actually, let me just zoom out a little bit. I forgot I'm on this whiteboard. I can zoom out and give myself a little bit more space if I need to. So equals one plus sine theta cosine theta on this side. Okay, so we have a common factor here, and that's sine squared theta plus sine theta cosine theta plus cosine squared theta equals 1 plus sine theta cosine theta. If you can see sine squared plus cosine squared makes 1, great. If you need to rearrange and bring them together to see that, that's good too. Sine squared plus cosine squared equals 1 by a Pythagorean identity. And we have left-hand side equals right-hand side. And we're done. And that's it for this video. We'll come back next time and keep talking about topics from 6.4. See you for the next video.